Now we start our lecture. Lecture number 7. The theme of our lecture is interchangeability.
Yeah.
And control of straight slide splines. Straight-sided splines. Please write down to your notes plan of our lecture.
Okay, teacher.
7.1 Classification of splined joints. Uh, 7.2 Spline joints connections with a straight-sided profile. Seven point three centering of splined joints. And 7.4 designation of spline joints or connections with a straight-sided profile. Now we start item 7.1 classification of splined joints. What is splined joints? Spline joints or connections can be considered as multi-K in which the Ks are made together with the shaft or bushing and are evenly spaced over the entire surface of the circle and parallel to its axis. Depending on the profile of the teeth, splines can be of three types: straight-sided, involute, and triangular. In these figures, you can see the splines with straight-sided teeth. So, splined joints. Splined or toothed joints are joints formed by projections on the shaft called as splines, which fit machining grooves in the hub. Please write down to your notes what is the splined joints. One more time, splined joints are joints formed by projections on the shaft called as splines, which fit machining grooves in the hub. One, it's a shaft, and two, it's the hub.
Yes, teacher, you can come, please.
Classification of splined joints. According to the shape of splines. Joint with straight-sided splines. You can see this type in figure 1. Joint with straight-sided splines. Next type of splines, it's joint with involute splines. You can see the teeth of these splines has involute form, like a G, and joint with triangular tooth splines. The teeth of the spline is like triangle. So write down to your notes these 3 types of splines, and write down to your notes 3 figures with different types of splines, of spline joints. And according to the depth and number of splines, the splines can be light series, medium series, and heavy series. Internal and external spline teeth. The tool machines and extensive hobbing and cutting tools available to us allow us to achieve external and internal spline connections according to the standards NBN, DIN, BS AGMA, or NF on G blanks, of which the dimensions fall within the limits of our manufacturing capabilities. This applies both to spline connections with involute flanks as for spline connections with straight flanks. You can see internal diameter of the spline connection, external diameter of the spline connection, and width of this B. Internal diameter, it's D suffix 1, D1, external diameter D2, and width of this, it's B. Splined joints. Advantages. Splined joints offer a higher load carrying capacity owing to an increased contact area. They permit better alignment of the methane parts. Stress concentration is less pronounced at the roots of the splines than in cage slots. Splined joints are easier to manufacture. They can be made to a higher degree of accuracy. Please write down to your notes advantages of splined joints. Splined joints compared to cade ones transmit more torque, have greater endurance strengths, and higher centering accuracy. Next slide.
Another 1 minute, teacher, please.
Okay, okay. Before we start the item number 7.2, let's watch some video about spline connections. Spline.
Splines are ridges or teeth on a drive shaft that mesh with grooves in a mating piece and transfer torque to it, maintaining the angular correspondence between them. For instance, a gear mounted on a shaft might use a male spline on the shaft that matches the female spline on the gear. The splines on the pictured drive shaft match with the female splines in the center of the clutch plate, while the smooth tip of the axle is supported in the pilot bearing in the flywheel. An alternative to splines is a keyway and key. Those splines provide a longer fatigue life. Types. There are several types of splines. Parallel key spline, where the sides of the equally spaced grooves are parallel in both directions, radial and axial. Involute spline, where the sides of the equally spaced grooves are involute, as with an involute gear, but not as tall. The curves increase strength by decreasing stress concentration. Crown spline, where the sides of the equally spaced grooves are usually involute, but the male teeth are modified to allow for misalignment. Serrations, where the sides of the equally spaced grooves form a V. These are used on small diameter shafts. Helical splines, where the equally spaced grooves form a helix about the shaft. The sides may be parallel or involute. This can either minimize stress concentrations for a stationary joint under high load, or allow for rotary and linear motion between the parts. Ball splines, where the teeth of the outer part are implemented with a ball bearing to allow for free linear motion even under high torque. Uses. Drive shafts on vehicles and power takeoffs use splines to transmit torque and rotation and allow for changes in length. Splines are used in several places on bicycles. The crank-arm to BB shaft interfaces that are splined include ISIS drive, Trovative GXP and Howitzer, Shimano's Octolink and many others, most of which are proprietary. Some cranksets feature modular spiders, where torque is transmitted through splines. Cassettes engage the free hub via a spline that is one groove wider than the others to enforce a fixed orientation. Disc brake mounting interfaces that are splined include Centerlock, by Shimano. Aircraft engines may have a spline upon which mounts the propeller. There may be a master spline which is wider than the others, so that the propeller may go on at only one orientation, to maintain dynamic balance. This arrangement is commonly found in larger engines, whereas smaller engines typically use a pattern of threaded fasteners instead. Manufacturing. There are two types of splines, internal and external. External splines may be broached, shaped, milled, hobbed, rolled, ground or extruded. There are fewer methods available for manufacturing internal splines due to accessibility restrictions. Methods include those listed above with the exception of hobbing. Often, with internal splines, the spline portion of the part may not have a through hole, which precludes use of a pull/push broach or extrusion type method. Also, if the part is small, it may be difficult to fit a milling or grinding tool into the area where the splines are machined. To prevent stress concentrations, the ends of the splines are chamfered. Such stress concentrations are a primary cause of failure in poorly designed splines. See also, hearth joint, key joint, reading, coupling. References. Further reading, Robert Rich Robbins. Tooth Engagement Evaluation of Invalid Spline Couplings. Brigham Young University. Retrieved July 8, 2010.
Let's watch the second video.
Mosier Minute. Today we're going to talk about axle spline. One of the most frequent calls we get is, what is an axle spline, or how do I measure an axle spline? Well, the axle spline is the peaks and valleys on the end of an axle that slides into the differential or spool. When we ask you what your spline count is, what we want you to do is count the number of peaks on the axle. Here in front of me, we have some of our most popular axle spline, starting with the 26 spline C-clip axle and progressing all the way up to our 40 spline race axles. This is our 26 spline OEM replacement axle. It measures just over 1 inch in diameter. This is our 40 spline, which measures just over 1 3/4 inch diameter. When you have more power, you need more spline. Another question we often get is, when I replace my OEM axles with a Mosier axle, how much strength am I going to obtain? Well, the Mosier axle, comparatively speaking, spline to spline, is approximately 30% stronger than your OEM axle. This is one of our C-clip axles. Typically, these are found in OEM type vehicles, including GM 10 and 12 bolts and Ford 8.8s. They serve the OEM industry well and provide adequate support for these types of vehicles. However, when you start making more horsepower and put them in a racing environment, you need more strength than a C-clip axle can handle. Once you get to that point, Mosier recommends a bolt-in style axle. It is far safer than your OEM style C-clip axle. If you have a problem in the differential or with the axle spline breaking, you don't want the axle exiting the vehicle. We're often asked, what is a contingency paying axle? We recognize 30 spline or above, or the equivalent of 1.285 inch diameter axles that are also positive retention. But in order to qualify for any money, you have to run 12-inch decals on both sides of the vehicles, along with the Mosier end cap visible at the time of the race. We offer a 10-year warranty on all 33 spline and larger positive retention axles in a drag racing environment. In order to qualify for a warranty, it must be on an asphalt or concrete type racing surface. If you're not sure what spline your application calls for, give us a call at 260-726-6689. One of our knowledgeable technicians will be happy to assist you and put you in the
And how to cut splines on the shafts. Cutting process.
Quick video today, I hope. The cousin of a friend of an acquaintance of a complete stranger, who evidently doesn't care to have a real machinist do this right, asked if I could machine a PTO adapter, specifically just the male PTO features, which fundamentally is a standardized spline. In this case, a standard 1-inch 6-spline fitting with parallel sides. PTO stands for power takeoff. You may have seen these things sticking out the sides of farm and garden equipment. They're like electrical outlets, but for mechanical power. You'd plug other stuff you want to power onto them, like log splitters or mowing attachments, that sort of thing. I've never cut one of these before. And after learning that it's some sort of hack backyard project, and more importantly, no one can get hurt here except their wallet, I said, what the heck? First thing I had to do was find information on the 1-inch 6-spline PTO shaft. Of course, I turned to the machinery's handbook. Fortunately, this thing has all the information I'll need to pull this off. And since I'm only responsible for the actual spline, we'll knock this back down and take it over to the mill. You likely saw this coming, but I'm set up in the dividing head. I didn't make this part. This is as received. The owner, from what I understand, has a lathe and a welder, and on close inspection, probably also an angle grinder. That, or more than likely, they tried to test fit this on a bearing or whatever this attaches to. Best I could do is get this thing centered to within about 1.5 thou. That's total run out. After 20 minutes, I've given up and calling that close enough. According to the good book, if I do the rest of this right, I should still be intolerant. That and their finished OD, where the spline goes, is a bit undersized. Let's pontificate a moment, shall we? Without being a complete and utter about it, of course. Here's what I think happened. They held onto this part here, same place I'm grabbing it with my dividing head. Probably obvious enough, right? And turned down the features that they needed. The 1.5 thou I'm seeing now is from their 3-jaw chuck. I mean, maybe a little is coming from this 3-jaw too, but I bet most of that was just their chuck and working off the OD of raw stock, which is fine. They also took a skim cut here on the large diameter, and if we could cut the back of this part off, we could grab that and be in a better situation, concentrically speaking. But they either went to town on this and took their measurements hot, or they used an older, worn PTO to figure out what the dimension should be. In either case, our major diameter is now undersized. What does that all boil down to? Well, I'm not going to volunteer for the extra work to get this thing dead nuts, or in metric, spot on. I agreed to do this for a couple of reasons, and on the premise that I might not be able to pull it off. First, like I said, I've never done anything like this before. I've never cut a PTO spline. And second, I don't have the right cutter to do it. All I have is a regular milling cutter. And I'm curious to know if I could approximate the PTO spline using one of these. These splines have a minor diameter. That means in between the splines, it's round. And technically, I would need a form cutter of the right size to do this. Something that in one pass would leave a finished spline profile. This cutter is going to leave that minor diameter a bit faceted, I guess, depending how much I approximate it. Hopefully that'll make more sense as I work through this, if this works at all. You might be wondering why I'm not using just a regular end mill for this, and that's good. I briefly considered the same thing. Using a regular end mill like this to cut the splines would result in an abrupt end to that feature. Like where it stopped, it would look like a key seat in a shaft, just like a sharp inside 90-degree corner. I couldn't find anything specifically in the book. I didn't dig too hard, but PTO shafts usually have that cut feature taper out. So if I come in here with a milling cutter and do the same groove, that cut will feather out. It won't stop abruptly. I don't know if that's necessary, if it's done to reduce stress concentrations, or if it's just a result of the manufacturing process. In either case, I'd like to mimic that lead out on the spline cut. So I'm going to use one of these. Somehow, all of a sudden, it's the next day. Time flies when you're having fun. Got the milling cutter mounted on my 80 RPM 0.5 inch per minute mandrel, 12 to 13 millimeters per minute. A bit perhaps on the conservative side, but this looks to me like a reground cutter. I've never used it. It feels sharp, but I don't know how well it's going to do. I'm going to start off slow and see how it works. I've snuck in behind here to pick up the height of the workpiece, the top of the workpiece. I'm going to use that to set the height of the cutter. And this is what I end up with after 12 passes. I did 6 cuts on one side of the spline and then 6 on the other. It's left me with these little pyramids here. That's the faceting I was talking about earlier. I'm now going to come in, 6 more cuts and try to knock those out. We'll see how that looks and take it from there. And there it is. It's probably not going to end up on the cover of National Geographic, but according to the numbers, this thing should work. I did my best to get in there and deburr it with a couple of small files and a stone. I didn't do an exceptional job. You can see some scuff marks here and there. I'll probably hit this with a little bit of Scotch-Brite or a wire wheel or something just to make it look a little more uniform. But as is, there aren't any sharp corners, so no one should get their hands torn up on it. Lessons learned? Well, just like most things in machining, the first time, once, is always fun. But if you had
It's process of milling of splines on the shaft. We use CNC system. It was external splines, and one more video to cutting of internal splines. About cutting of internal splines. So we return to our presentation. And we start item 7.2, spline joints with a straight-sided profile. The most widespread are splined connection with straight-sided tooth profile, the lateral sides of which are parallel to the axis of symmetry of the tooth until they intersect with a circle of diameter d. The standard specifies the number of teeth, the nominal dimensions of such a light, medium, and heavy series connection, as well as tolerances and fits for connections with centering on the inner, outer diameter and on the sides of the teeth. Spline connections with a straight-sided profile. Spline connections with a straight-sided tooth profile are characterized by three sides: small d, like in this figure. Small d, its internal diameter. Big D, its outer diameter. And B. Between these parameters, due to the imperfection of the technological processes of processing, there are errors in the relative position of the connection elements, which do not make it possible to perform centering on three-dimensional parameters at once. Since the type of alignment is directly related to the choice of tolerance fields for individual elements of the connection and their fit. The assessment of tolerances is determined by the adopted method of alignment. Please write down to your notes this type of our slide. 7.3 Centering of splined joints. Centering of splined joints. Outside the diameter centered. Big D. It's outside diameter centering. Is the simplest and most economical option and is recommended when the bushing is not threaded, or when its material is hard enough to be sized by pulling, and the shaft material is milled to final tooth sizes. In this case, the centering surfaces outer diameter, big D, and the spline with B. Allow for precise and productive processing, the bushing by broach and the shaft by round grinding. Due to the low strength of the bushing, this method is used for fixed joints, no wear, no clearance, as well as for movable ones that perceive small loads. Next type of centering of splined joints. Centering on the inner diameter, small d, inner diameter of the spline, small d, is advisable in cases where the bushing has a high rigidity and cannot be machined by finishing broach. Then the final dimensions of the bushing are obtained after head treatment on conventional intra-grinding machines. This method provides precise centering and is commonly used for moving joints. It was the second method of centering of splined joints. The third method, centering of splined joints, it's centering on the side surfaces of the teeth. B. side surfaces of the teeth. B. Is used in cases where the centering accuracy is not of particular importance, but it is required to ensure sufficient strength of the connection in operation with alternating loads, high torque use, etc. With this variant of centering, the load is more evenly distributed between the teeth. However, centering details are less accurate. So you should write down to your notes 3 types of centering or splided joints. Centering on the side surfaces of the teeth, centering on the inner diameter, small d, and outside diameter centering, big D. Recommended fits in splined joints. The standard established The standard establishes recommended fits on spline dimensions depending on the centering method. 20 tolerance fields have been established for the centering surfaces of the shafts of grades from 5 to 10 with the fundamental deviations D, E, F, G, H for the formation of clearance fits, as well as J, S, K, N for transitional fits. For non-centering surfaces, it is established when centering on the inner diameter D. For the outer diameter on the shaft, the tolerance field is A11. For the outer diameter of the bushing, H12, big H. When centering on the outer diameter, big D, for the inner diameter, the tolerance field H11 is set for the bushing, and for the shaft, the tolerance field is not standardized. The numerical values of the main dimensions and tolerances are taken as the standards for smooth cylindrical surfaces. Please write down to your notes information about fundamental deviations and information about fundamental deviations and grades for non-centering surfaces of splines. The designation of splined joints and their parts includes the method of centering, the size of its main parts and their fits. The method of centering, in the first place, is centering by inner diameter. The number of the teeth, 8 teeth. Its internal diameter, nominal size of internal diameter, small d. its outer diameter, nominal size of outer diameter, big D, and nominal size of width of teeth, it's B. Nominal size of B. And their feet of on the inner diameter, feet on the outer diameter, and feet of the parameter B. It is allowed not to indicate the tolerances of non-centering diameters in the designation. One variant of the designation of spline joints, it's without parameters on non-centering diameters. Our connection centering by small d, inner diameter. We should indicate this diameter, but we don't indicate the fits of the outer diameter and B. Only nominal dimensions without parameters of their fits. An example of designation of a connection with the number of teeth that is equal 8. Inner diameter, small d, 36 millimeters, inner diameter. Outer diameter, big D, is equal 40 millimeters. Tooth width, B, is equal 7 millimeters, which centering on the inner diameter, with centering on the inner diameter, with feet on the centering diameter H7 divided E8 and size B D9 divided F8. Write down to your notes this example of designation of connection of spline connection. Please do it now. So our time is finished. We finished our lesson. So goodbye. See you next time.
Goodbye, teacher. Thank you so much for today.
Goodbye.